Hello and welcome to another video of Vidhai. This time we are going to learn about the chapter light and let's get into the video. I am a volunteer from the Vidhai Exams Possible team here to teach the chapter about light for the exam NMMS. Without further ado, let's move on to the video. Before going through the video, I shall tell you the content of the video that we are going to cover. The first, we are going to see the mind map of the chapter light, then followed by the mirrors such as the plane mirror and the spherical mirror, then the terminologies of the spherical mirrors, the basic laws of reflection and the basic laws of refraction, some sample questions from previous year NMMS papers, and some exercise for you to work on. The mind map. But before that, let's see the crude definition of light. What actually is light? It's a natural agent that stimulates sight and makes things visible. What does this mean, you may ask? It's light that makes us see all the things around us. It's because of light we can see the blue color is blue and the red color is red. That's the reason why light is such an important feature around us, in the surroundings. Now let's look at the mind map. So you have the mirrors, the terminologies, reflection and refraction as some main subtopics which I have shown in the previous slide as well. So first we are going to take a look at the mirror. So under the mirror we have the curved mirrors and the plane mirrors are sorted down into many other subtopics like the spherical, cylindrical, parabolic and episoidal. We are going to focus on the spherical and the parabolic only, and the spherical is divided into concave and convex. We'll be seeing that in the future of the video, and then let's move on. So what is mirror and what are the types of mirror is the first question you may ask whenever you are shown a mirror. What is this? Mirror is an object that reflects an image. That's simple as that. You stand in front of a mirror, you see an image of yourself. The mirror being divided to subtopics like I shown in the mind map. Here the mirror is divided into plane and curved. So the curved is divided into spherical and parabolic. The other two we won't be seeing in the video because they won't ask it much in the exam. So this is how a plane mirror looks like. It's just a plane mirror. You guys have seen it very often. You guys wouldn't have seen is the concave and the convex mirror, which comes under the spherical mirrors. So these two are two different spherical mirrors. You can see a man's face being enlarged and his body and face being diminished. Like it curves the image like such a manner. It has special properties that we use this in many applications, such as the rear view mirror, or you can see these type of mirrors in really crowded places like shopping malls or parking lots especially, or even at the turning of a road. You can see that convex mirror. This is, by the way, the convex mirror. Suppose a light is coming like this, it reflects back due to this curved nature and goes at some other angle. We'll look into this curving nature and why it's reflecting back that way in the future of the video. But for now, you may notice that the spherical mirror here has a special property of bending the image such a manner that to get a wide field of view. So the mirrors that we are going to study is spherical and parabolic only, right? And the spherical is further divided into concave and convex. So the plane and the curved mirrors, first we need to go into the mirror itself. What is mirror? What is it made out of? So the mirror is basically a glass sheet coated with aluminum or silver on one of the sides to produce an image. Why coat a glass sheet with aluminum or silver? Aluminum or silver are both two shiny metals that will reflect light. You can just see how silver and aluminum are just shiny, that they reflect light smoothly. That's the reason why you can see a light being shiny on many of the metallic surfaces like zinc, gold, silver, but not for diamond. Diamond is not a metal. It's a different topic which we'll cover it in later video. Metals usually reflect light. That's all you need to know, and they are shiny because of it also. Mirrors have a plane or curved surface. Curved surface are of spherical form or in a parabolic form. So the shape of the mirror determines the image form as well. So a plane mirror will form the image at the same size of the object. Suppose you stand in front of the plane mirror, you can see your image being at the same height as you as well. Nothing else is changing. Your face is not being widened, your face is not being diminished. It's just as it is. So the plane mirror, you can see here a man is standing on one side of the mirror and is looking his image on the mirror. He's looking exactly the same. So the plane mirror has the ability of producing an image which is same as the object. The object here is the person. Now you have the concave mirror. What's interesting about this concave mirror is majority of its images produced is inverted. Now we have a coffee cup on a table. You can see the image is being inverted. Like now the coffee is standing upside down on the table and the table itself is being inverted. You can see that. Then you have a convex mirror. Like I said, convex mirror majorly present on the corner of the road to see incoming and ongoing traffic. So you have a direction pole here of the road and you have a convex mirror attached to it, so you can see which vehicles going and coming off the road. What does this do is give a wide field of view to see what are coming outside your view. So let's move on to the next slide. Spherical mirror. Now we are going in depth of the spherical mirror. We'll be calling the spherical mirrors to be a part of a sphere. A sphere is nothing like a ball. So this is the sphere, right? You take a part of the sphere like this. Alright, you take a part of the sphere and then you silver. Remember in the definition of the mirrors, when you silver a side of a mirror with aluminum or silver, it becomes shiny and then it becomes as a reflecting mirror. So here, when I take this part and I shine it outside the sphere, it becomes a convex. And here in this part, when I shine it inside the sphere, it becomes concave. I'll show you later in the video clearly that idea. So you have this enlarged image of this part. So this side when you shine it, like this side when you shine it, it will become a concave part. This is the concave part. You go from here to here, you can see how bulged inwards it is, right? Now you have a convex part, like when you come from right to left, it's bulged outwards in respect to you. You are here and you see this part being bulged towards you, but when you're here, you can see these part bulged away from you. That's basically the concave, which is bulged out, as in the caved manner, bulged in, caved in, and convex part, which is the opposite of concave, which is bulged out, which is bulging towards you. Concave, these mirrors magnify the object placed close to them. Most common example of a concave mirror is the makeup mirror and a dentist mirror. And convex mirror, these images formed by these mirrors are much smaller than the object but give a wide field of view. Most commonly used convex mirror are the rear view mirror in the vehicles. So you have the dentist mirror, which they put it through your mouth to see any cavities are there or not. That's the mirror that's actually bulged in. It's so small that you can't see it, but it's actually bulged in. Next time if you go to a dentist, you can just ask them to show the mirror. You will notice that it will be bulged in. So this is the rear view mirror that you see in most every vehicle that you see. Like it will be bulged out, so smooth that you won't recognize it, but it's actually bulged outwards. So this goes on to the next a curved surface mirror, which is the parabolic mirror, which is different than the spherical mirror that we have seen before. So parabolic mirror is a curved mirror in shape of parabola. So what exactly is a parabola? Is something like this. It's not too bulged out or in. It's a shape that I'll show you later in the video. Parabolic mirrors are also known as parabolic reflectors. They are used to collect or project energy such as heat, light, sound, and radio waves. So this is a parabolic mirror, and the reason why many people choose parabolic mirror over the spherical mirror, I'll tell you the reason in just a jiffy. You can actually see a parabolic mirror right at your home if you have those dish TVs, something like this. This mirror, this curved surface is actually a shape of a parabola, not a ball. It's not a spherical surface, but rather a parabolic surface. So let's take a closer look on these mirrors that we have discussed. Alright, now let's take a closer look on the types of mirrors that we have seen. Now starting with the plane mirror. So the plane mirror is just like a normal mirror like this. Just a normal mirror. We would do this dashed line to say that this is not the mirror side, and this plane side to be a mirror side. With that being said, we are going to use this notation to show which side is the mirror side and which side is not the mirror side. Now you know a plane mirror will just be a normal plane mirror, so let's skip on to that and go to the concave mirror. So the word cave just reminds of a cave, basically a cave. So you're going to draw a cave like this. Right. Now, in the slides we have noticed that this side is the concave side. So the concave side, and I'm going to use that same notation to show the non-mirror side. This side is completely blacked out, like this side is not present, only this side is present. So the light ray which comes through this will be reflected in such a manner. Suppose a light ray comes from this manner, will be reflected in some other manner, giving an image that is inverted or enlarged. Now let's go to the convex mirror. Convex mirror will be like this. It's the opposite of concave mirror, and now I'll put the markings here. Now this is the convex side. You notice the difference between concave and convex side. The concave side is bulged inwards. When you're coming from this side to this side, you can see it's bulging inwards. When in the convex side, when you come from left to right, it's bulging outwards. So these are the two main difference between these two mirrors of such manner. Now let's go to the kind of a complicated mirror, which is the parabolic mirror. Parabolic mirror and the concave mirror are both the same. So in a parabola is not a sphere but rather an oblique shaped. So a parabola will be looking like something like this. It will have a really sharper blunt edge than of the concave side. So the parabolic mirror will have, so this is the mirror side, this is the non-mirror side. You have the mirror side and non-mirror side. Now the difference between this parabolic and this spherical mirror is parabolic mirrors work in higher efficiency of reflecting light, and its focus is much more sharper. The focus sharper and have high efficiency of reflecting light than of the spherical light. So this is the spherical and this is the parabolic. With that being said, let's move on to the terminology of the mirrors. Alright, for the terminology is a bit tricky, but when you get a hang of it, you will understand what's going on. So the terminology in mirror, there are two types of terminology we are going to study in for the mirror and for the image and object that is being formed. So for the mirror, you have the center of curvature, pole, radius of curvature, principal axis, focus, and focal length. For the image, we have real, virtual, enlarged, diminished, erect, inverted. Real and virtual are together related, enlarged, diminished are related, and erect, inverted are related. Now I'll show you a detailed hand-drawn terminology explained. Right. We have seen the slide of the terminologies with just words in it. We haven't yet seen what it actually means. So we are going to take a sphere, a circle. You know, a 3D object of a circle is a sphere. So how I'm going to draw is like this. It's a normal sphere. It's just like a ball, but in the 2D plane it will look like a circle. Now you know all spheres will have a center. Suppose this is the center. Now we have seen in the last slides that when you take a portion of a sphere, it will form the curved mirror, right? So you take that curved mirror out of the way. So let me draw this. Take the curved mirror out of the way. Now I can silver it in this side or this side depending on the concave which I need or the convex which I need. So here I'm taking concave mirror, and this mirror, you know, it has a center in its spherical form, and that center of this mirror is called the center of curvature. It's the center of curvature. Now we get the meaning of this mirror. Now let's take a plain mirror. Now let's take the mirror alone, not from the sphere. So let me draw a mirror which is like this. Now we have a center of curvature here, C, right? I name this point as C, which is the center of curvature. Now I connect this to the mirror such a manner it's perpendicular. Now if I to draw this line on the sphere, it will look like this, which is the radius. Now which is the radius of the sphere. Now you can see this point, right? This point we're going to call P, and that point which meets the mirror from the center of curvature perpendicularly is called pole. Now that's the second point that is in the terminology slide. Now you remember that I call this the radius of the sphere, and here the same radius of the sphere. Now this radius of the sphere is having a term of radius of curvature, right? This is the radius of the curvature, the R, which is equal to the radius of the sphere that is it's from. So this radius of the curvature and the one more terminology that we are going to see will have a relation. The other next point is the principal axis. Now you see this line there, right? A line here. So that line is called the principal axis. Now you know the x and y axis have in the 2D graph, it has no ends at all. It will keep on going. It's a line. So the line which connects the pole and the center of curvature is called the principal axis. Now let's move on to the focus. Now I'm going to divide this line segment which is from C to P, which I will divide into 2 equal halves and name the midpoint as F. Now this F, which divides the line segment between C and P, is called the focus. Now this length, the length between F and P, you have this length, right? That length is called as focal length. Now the relation between this CP and FP is 2 FPF line segment length is equal to CP. That is the line, the F divides the line CP into two equal halves. Now this finishes the terminology in the mirror. Now let's move on to the terminology in the image. Now the terminology in the image is real. Now let's talk about real. Real is something of an image which two real lines light will meet each other. So you have an object here, right? You have a ball here, you have a cube here. We call them as real objects. It's simple as that. Whatever you can see are real objects. Now virtual objects are something that you see behind your TV. Like in the television, you can see a man walking in here. That man is a virtual image. The light rays come from this TV, ends up in your eye, but the man inside the TV is a virtual person. He's not right now inside your TV, but he's somewhere else. It's been broadcast virtually. Now let's talk about enlarged image. Now you have seen a magnifying glass. This magnifying glass will enlarge a small object as a big object. So let's take a ball here, and when you place the magnifying glass, the ball will look to be a bigger ball. This is called an enlarged image, an enlarged real or virtual image. Now let's go to the diminished image. Now the diminished image is just an opposite of it. You have a bigger ball which will turn into a small ball. Now that's diminished. Now let's take a look at erect and inverted. So let's go to erect first. The erect object is you have a ball standing in the ground. It's on the ground. And when you look at the ball, you see the ball being standing up the ground, right? It's called erect. You can see a person rather, standing up the ground. Now that's called an erect person. He's standing up the ground. Let's look at the inverted. The inverted is just like the man, instead of standing on the ground, he's below the ground. So the man will look like this. He's below the ground. Alright. Now we will use this type of notation as a very important one. Instead of the man, we'll notice, or you will notice that I'll be using something like this. An object with an arrow mark on it. Just assume this has a head and this has the tail. So instead of a man like this, it's the arrow mark. This is an erect image. This is the inverted image. Alright. So this is a diminished image. This is an enlarged image. And this is going to be a real image. And the virtual image has a special notation. Like we will draw the arrow mark in dotted lines. Now this is the terminology in images. We have real, virtual, enlarged, diminished, erect, inverted. I'll go over this once again. Real are every object that you see in your daily life. It's a real object. Virtual is like the man behind the TV. All the images that is going across your TV are all virtual. They don't exist, but you are able to see it. That's virtual. Enlarging is like seeing an object through a magnifying glass as a small ball becoming a bigger ball. The same for diminished. A big ball will turn into a small ball when you look through a mirror or a lens. Erect is something like a man standing up the ground. Inverted is something like a man standing upside down on the ground. Now we use these arrow marks to notate the real, virtual and all the other things of the image property. Now with that being said, let's move on with the next slide. Now we move on to the applications of the mirror. So we have seen how a concave mirror look like, we have seen how a convex mirror look like, and most especially we know that parabolic mirrors are not same as the spherical mirrors, and as well as the terminologies. So why do we study mirrors? What are we going to use this for? So the concave mirror is used for when applying makeups. In the concave mirror, the object when you place close to the mirror, it will show the image much more bigger, and for shaving as well. So and as they provide the magnified image. They are used in torch, searchlights and headlights. You can see the headlights of a vehicle. Behind the bulb, you can see a reflecting surface. That reflecting surface is in the shape of a concave shape. So when they produce light, these reflecting surface reflect the light such a manner it will be spread out to a really wide area. So you can see further into the darkness in front of the vehicle. And they collect the light also, like instead of dispersing, they also collect the light and focus at one point. Like at a really high temperature, it can focus at one point using a solar cookers. Okay, and then you use the application of point number 2 in dentistry. The dentist will wear a concave mirror on the forehead to provide light from the surrounding light. So this is the headlight that we have seen. This is the search or the torch. You can see this reflecting surface inside the torch, right? And you can see the bulb. When you on it, that bulb light will reflect onto that mirror and then spread out to a really wide area, really further into the darkness. Now this is the makeup mirror, right? So the more closer you are to the mirror, the more enlarged your image will be. So these are the two applications of mirrors for the concave mirror. Now we'll go into the convex mirror. Convex mirror are used in rear view mirrors. We know that, we have seen it. And then they are found in hallways and buildings and usually at the turning of the road. So what this basically does is give a wide field of view. So that's basically the convex mirror does, but it's consistent in every case. So this is the rear view mirror that we have seen in previous examples. You can see this is a concave mirror, convex mirror, sorry, not concave, convex mirror, and this is much smaller radius of the convex mirror. So this is so sharper than this curved surface. And now we have this convex mirror lying at the corner of the road. You can see this man standing here. He can see to his left and right whether the car is coming or not. This is a really good use of a convex mirror. Thank you for watching this video, and this is just the part 1 of the video where we discussed the types of mirrors, the terminology of the mirror and the images. Now in the next video, I'll be showing you how the images are being formed in front of the mirror. Thank you for attending and we'll see you in the next video.